Hi there, my name is Michael Sines. I am in the PM class for Physics 201, and I am a computer science major. I wanted to welcome you to the Build-A-Tron. The Build-A-Tron is more than just a toy. It's actually a hands-on learning experience that's designed to spark curiosity in children about exactly how the physical world works. By assembling the robot themselves, kids engage with the fundamental concepts in physics, such as energy transformation, motion, and simple machines in a way that's very intuitive, engaging, and fun. The robot is completely buildable from scratch. Kids connect the arms, the legs, and wind-up mechanisms with safe parts that give them a sense of ownership and accomplishment. Once they're built, they can twist the gearbox and watch the robot move, visually experiencing how potential energy stored in a spring becomes kinetic energy that powers motion. What makes this toy very powerful is exactly how it bridges play with learning. Kids will have fun through guided experiments, and creative freedom to decorate their own robot. And children aren't just entertained, they're actually being introduced to the building blocks of science through action, experimentation, and problem solving.
I am Michelle Willard, and my major is pre-engineering, and in my future, I hope to transfer to Cal Poly Pomona. Greetings and salutations! I am here to discuss the process of manufacturing that shall occur to create this automaton. Within the blueprints for our design, which we sent to the toy company, we gave the measurements and what materials were expected. Within our plans accepted by this toy company, they would send our designs to the manufacturers. Unlike the days of old, these toys will not be made by hand, but in a factory, upon a production line. This toy shall be made with the assistance of various machines with moldings that make the process easier and cost-efficient. This toy shall mainly be made of plastic, with a small exception of its inner workings. However, the assembly also lies within the hands of our consumers. Our toy does not come pieced together, but separate. Parts that click together to make a wind-up robot. The Build-A-Tron, living up to its name, within an eco-friendly box with stuffing, is our product. Our consumer shall have a small black box that includes the gears for which move our robot. A separate piece, the winder. The pieces for the body, in which a black box shall be inserted like a battery. Then, with one more click, a lid shall seal the deal, and this toy is ready to go, go, go.
Hello, my name is Mark Horton. I am currently attending Citrus College to transfer out. My major is electrical engineering, and I plan to transfer to Cal Poly Pomona once I'm done at Citrus. Anyway, the toy functions like most wind-up toys would. Firstly, when you twist the winder of the toy, it begins to add lots of tension to the spring stashed inside of the black box. Once you wind it up enough and give it enough tension, the spring in the model is designed to store up lots of tension, allowing it to unwind and spin the gear. Once the gear begins to rotate, it is touching another rigid surface pole, thereby spinning said pole. The pole is connected to the offset cylinder, which rotates the leg poles in a clockwise direction, therefore allowing the toy to move. It will have a waddle type of movement, much like a penguin. And, once the wind-up stops, the toy shall begin progressing forward.
Hello, my name is Noah Rodriguez, and I am a physics major, and I plan on transferring to Cal Poly Pomona after I'm done here at Citrus. I'm going to be going through some of the physics concepts taught by the Build-A-Tron. And just to be clear, the children who use Build-A-Tron will learn these concepts solely on a very basic level, but it will lay a good foundation for future physics learning. So yeah, let's get into it. So first up, we have kinematics. As a child plays with their robot, they'll be able to see a live demonstration of displacement, velocity, and acceleration in action. So they'll be taught that how far the robot travels is called its displacement. How fast it's going is called its velocity. And when it goes from stopped or at rest to its top speed, that's called acceleration. So again, just a basic kind of identifying what these things are for the child. The next concept that will be taught by the robot is friction. This is very easy to demonstrate. As the child uses their robot on different surfaces, they'll be able to see that it moves differently on a smooth countertop than it does on a rough carpet. And they'll be taught that this is because of a different force of friction that's exerted by each of these different surfaces. The next idea that children will be introduced to is the idea of kinetic energy and energy in general. And they'll be taught that energy is just the ability to do work or the ability to do things. And that when things are moving, they have a specific kind of energy called kinetic energy. And to help them understand this idea of energy and kinetic energy, the battery analogy will be used in that children often understand the idea of batteries being charged and having energy. And so, just kind of making the comparison, showing that just like a battery has energy and we can use it to power things, this robot, as it's moving, has energy, and that energy is called kinetic energy. After kinetic energy, children will be introduced to another kind of energy, elastic potential energy, and the idea that when the spring inside the robot is twisted up, it now wants to unwind, and that's a form of energy, just like kinetic energy or the energy in a battery. The final two concepts that children will be taught about as they use the robot are the conservation of energy and the work energy theorem. Both of these will come up as it's explained to the children that the spring inside the robot is what powers the motion of the robot. And so the idea that the energy in the spring gets transferred to the energy of the moving robot. And then that's, of course, conservation of energy. And the work energy theorem comes up when we explain that the winding of the spring, that was hard, and that's work. And so that work then puts that energy into the spring. The energy doesn't just magically appear in the spring. We have to put energy in by the work we do as we turn it. And then that energy in the spring then gets transferred over to the energy in the robot as it moves via the gearbox. And so, yeah, that's all the physics there.